So hello, everyone. My name is Murtaza Zafer, and I'm just going to be talking about IoT classification and performance. And as Anand said in the beginning, all hard questions are for these two guys. So so we all know that IoT devices are actually coming onto the network in increasing numbers. And if you were to sort of go out and pick up any market report on IoT devices, you'll see that there are predictions of billions of these devices that will be online onto the network in the next few years. So and this is actually happening in all the verticals, across the board. Now, IoT devices are actually no more these fringe devices that actually come onto the network. In many verticals, these are devices that are actually very critical to the business. And so, just to give you an example, let's take the healthcare situation. There, if you think about infusion pumps, glucometers, ECG monitors, these are all devices that are very critical for healthcare and for the health of the patient. And so, these are not just devices that are just coming onto the network, but these are devices that are actually impacting, business functionalities. Similarly, if you were to look at manufacturing, you have robotic arms, devices on the assembly lines, and these are again very critical for the business and for the assembly line to actually function. And so it's needless to say that the user experience of IoT is not something that you just want to know about, but it is something that you actually have to care about for the business. The other thing that's also happening is that IoT devices, just like other devices on the network, can be bucketed into two broad classifications. One is these managed devices, and then the unmanaged devices. Managed devices are basically something that the IT team is actually aware of. These are managed. They have all the policies behind them. But then on the flip side, there is these unmanaged devices, which are basically things that people connect onto the network. Say, for example, smart TVs, smart thermostats, and so on and so forth. And so one of the other important things for IT is actually just visibility, just knowing what are all the devices that are coming onto the network and that are sort of using the network resources. The other thing that actually matters to the IT is that these IoT devices have very quirky behavior. Not all of them, but some of them. And I'm going to actually, towards the end, just give you a quick snippet of some customer data that we have, which shows how the performance of the overall network and the performance of a specific class of IoT device can be very significantly different. And so it's not just enough to say that, okay, my overall network is actually doing good. But it's really important to actually understand how different classes of IoT devices are performing. And so the first step in actually getting there is to be able to even classify these devices into different buckets. So then we can actually go and slice and dice the data and then have all the power of voyance to give you all the answers on user experience. So, as you would imagine, IoT classification is a challenging problem. And so, we can start off with the traditional ways of doing device classification. So, for example, you can start with the MAC prefix. You can take the MAC prefix, you can map it to an OUI, and then from that, you can actually know the chipset manufacturer. You could also use some kind of DHCP fingerprinting, and then, look up a database, and then map that to a particular device type. If the device is actually managed, you can use the corresponding radius profile, the username of the device, to again bucket that device into a specific device type. If your device happens to be a laptop or a smartphone, which is again not an IoT device, but then for those devices you can actually use the user agent string and use that to actually classify that device. And of course there are also various other static kind of ways where you actually look at different fields, on the network data and make some classification. So these are all great methods, but the shortcoming is that they actually do not allow us to do final level classification. And so, for example, let's say if you pick the MAC prefix way of doing things, you can get to know what the chipset manufacturer of that chip that goes inside the device is, but you really cannot classify it beyond that. As we all know, the same chip can actually be part of many different IoT devices. Also, in many cases, Okay. Also, in many cases, for example, the user agent way of doing things may not even work for an IoT device because, that device may actually not be, using any browser-based method of communication. So, that does not mean that these are actually not useful methods. These are definitely useful methods. But what we want to do is we want to sort of augment these with some other approaches which are more, tuned for helping us, classify IoT devices. And so I'm going to actually talk about, the approach that we are taking, which is using behavioral analysis, how these devices behave on the network. But before going there, I just want to sort of, give you some idea about, the unique characteristics of these devices, and it's going to be sort of very instructive for us to sort of understand how these devices behave and how that actually translates into the data and the methodology after that.
Hey guys, question for you guys. Are IoT devices top of mind for you in any way? And have you guys sort of
definitely relevant?
Oh, yes, definitely.
Okay,
For sure.
All right.
But I have a question. Are we planning on going outside of the 2, 4, and 5 IoT devices? Are we planning on going out to 900 megahertz? Are we talking about LoRa? Are we talking? Are you going there?
We're starting with 2.4.
Okay, I need Nyansa and sprinklers. All right.
All right. So cool. That's good to hear.
Okay. So here's something. As we sort of start to think about IoT devices, these are sort of some characteristics of these devices that actually, that comes to, that sort of comes to our mind, which is, first of all, IoT devices are basically custom built for an application. So, take the example of ECG monitors. These are monitors that capture your electrical signal from your heart and send it out to the server, display it on a board. ECG. Yes, or your Apple Watch or one of those devices. But they are custom built for that application, and they'll do just that. And so these devices have a very limited set of functions. This is sort of in contrast to our devices, user devices, which actually run many applications. They'll talk to many hosts and do many things. But IoT devices will actually have very specific set of functions. The other very interesting thing about these devices is that on any given network, you actually will find many devices of the same class. So, for example, in the healthcare vertical, ECG monitors, right? Any hospital will actually not just have one ECG monitor, but a bunch of these. And so what happens is that there are many such devices on your network which are doing a similar behavior. That's kind of like an interesting point here. The other thing is that the behavior of certain classes of these IoT devices carries over from one network to the other. And again, this is actually a really powerful thing because now we can actually use cloud sourcing to understand the behavior of these devices and to better classify them. And this is something where Voyance has unique capabilities, just because of our platform, which actually has cloud sourcing built into it. Okay, so what I'm going to do in the next 2 slides is just give you some snippets of data that we gathered from our customers. And I'm going to just focus on the healthcare vertical and talk about 2 classes of devices in healthcare. But you can see, this sort of will carry over to other verticals like manufacturing and so on and so forth. So the first example I'm going to talk about is something called as Alerus infusion pumps. Again, just to give you a quick context, Alerus infusion pumps are basically these devices that help help the healthcare people deliver fluids into a patient's body through the IV line. And so what we did was we went ahead and analyzed thousands of these devices across our customers in the healthcare vertical. And what we actually found are a few of these very interesting behaviors. The first thing is that once we remove these devices actually talking to your radius, DHCP, DNS servers, these devices communicated with at most 2 internal servers. In many cases, actually, there was just one single server. And this was basically the Alerus server that these devices were talking to. So of course, intuitively, this definitely makes sense that you would do this. These devices would actually have this behavior. And also it sort of confirms to the intuition that we were sort of talking about in the previous slide, where these devices actually have limited functionalities and only do certain limited stuff. The other thing that we found was that these devices did not talk to any external host. Again, very intuitive. You wouldn't want Alerus or infusion pumps to actually go and talk outside the network. And in fact, but the thing is that this is actually not true for all IoT devices. I mean, clearly, if you had a Nest thermostat, it's going to talk to an external Nest server. But the interesting point is that this behavior can now actually help us classify, these Alerus pumps or separate Alerus pumps from, let's say, a Nest thermostat or devices that actually go out of your network. So, this is, how these behavioral patterns are actually now going in as inputs into classifying a device. The other thing we found was that when we looked at a 1-week period, 95% of these devices had traffic less than 10 megabytes. Again, very intuitive. These are just simple devices that are capturing some data and sending it out. But the point here is that if you sort of compare this to, let's say, an IP camera, the amount of traffic that an IP camera would carry would be much more than 10 megabytes. Again, a differentiating factor between an Alerus pump and an IP camera on your network. The other thing that we found was that when we looked at the OUI of these devices, the most common OUI is ZebraTech. Again, if, as I was talking about earlier, that if you were to sort of just looked at the OUI of a device, ZebraTech actually manufactures chipsets that go into many these devices. So by itself, ZebraTech doesn't tell you anything more. But now, in combination with some of the other stuff, the amount of traffic, how the host interactions are of these devices, you can now start to see, there's a differentiating behavior. Also, the last thing that we also realized was that some of these devices were using this RTMP protocol. It's like a real-time protocol, which is again very interesting because the first time you would see it, you would be like, oh, this should be associated with an IP camera, real-time streaming. And so by itself, it does not say much. But again, if it was an IP camera, it would actually have a much more traffic than what we see. So again, all of these factors in combination give you this differentiating feature. Okay, so the second example I'm going to talk about is something called as glucometers. Again, these are devices that actually help you measure blood glucose level. And for this case, again, we did the same thing. We went ahead and analyzed hundreds of these devices across our healthcare customers. And here's some of the stuff that we actually found. The first thing, again, similar to Alerus pumps, these are devices that talk to, at most a couple of internal servers. But the unique thing is that the servers that these devices talk to are different from the servers that Alerus pumps talks to. So, different application. Again, none of these devices actually talk to an external host, which is, again, pretty intuitive. If you looked at a 1-week period for these devices, most of these devices, more than 95%, had, again, less than 30 MB of traffic. Again, similar behavior to Alerus pumps, but in combination with the kind of host that these devices talks to, there's a differentiating factor there. When we looked at the OUI of these devices, there were actually 2 different classes of these glucometers, or 2 different vendors. One was the Abbott glucometers, and the other one was Roche. And what we found is that Abbott had this Silex Tech as the OUI, whereas Roche had the other OUI. And lastly, the other interesting thing that we found was that Roche glucometers were using FTP protocol when they were actually talking to the server. So again, by itself, each of these points do not really say anything about glucometers, but in combination, they are now trying to give you a differentiating behavior of this class versus some other class, and so on and so forth. Okay, so where are we going? So I just give you a quick a few snippets about how these devices are behaving on the network. So where are we going is we are going to actually now go and use this data to do what we call as the behavioral analysis. And so just to formalize that, we start off by capturing metrics that identify a device's behavior. And just a few examples of that are, let's say, the hosts that these devices talk to, the traffic patterns of these devices over time, any kind of periodic behavior in the access times of these devices with the corresponding hosts, and so on and so forth. And again, from Nyansa's perspective and just the Voyance platform, we sort of are well positioned because we already actually capture all of this data in our system.
With all of this data, are you considering doing like a security module that basically alerts and tries to do any kind of threat prevention or detection?
No, I mean, so right now we're sort of more focused on again, I don't know.
Sure. Yeah.
Well,
Today, we're focused on classification and performance. I mean, I guess there's a never say never aspect to anything or whatever,
Yeah.
but today, just because, all the problems that we solve are geared towards the client experience and looking at it from sort of end to end, that's kind of where this kind of fits in.
okay.
Yeah.
Okay, so now once we have all of this data, this data from across all our customers, again, cloud source data, we then sort of feed into machine learning AI model and sort of develop some model for a behavior of a device. And we sort of come up with this classes of behaviors. And once you have that model, we then sort of go and have some input from our customers, and as well as just general domain specific input to then go ahead and connect these behaviors to different classes of IoT devices. So once we have these models, we can then go ahead and apply these models across our customers to then help them sort of classify and characterize different IoT devices. Again, this is sort of started working on this, and it's going to sort of soon come into the Voyance Campus app. But for now, what we can actually provide are reports on different IoT device clusters that your network actually may have.
So is this going to feed into kind of a root cause analysis type of thing? So if you're collecting all this data, seeing the trends and what kind of Wi-Fi issues these devices are having, then you have this root cause that tells the user, this is the reason why you have performance issues.
Yeah, no, exactly. And we'll show you a couple of examples of that too from, again, sticking with healthcare for a sec, just of IoT devices and the correlation of their behaviors and stuff like that.
Yeah. Before you go ahead, are you planning on productizing this evenly across the portfolio? Because I could see plenty of enterprises that simply don't give a rip, right? And so or EDU space or whatever, right? I don't care about IoT. I just want to know if my wireless devices are working fine. And so it feels like we're starting to lump features in that may not be relevant to certain verticals.
Yep.
Is there an opportunity there to offset some of the cost concerns by productizing it and saying, hey, maybe if you don't care about IoT, maybe you don't need this little bit, or if you do care about IoT, maybe you should pay a premium.
For you, Sam.
Wait, I'm going to disagree with that because I'm tired of buying products that, I need to buy this module and that module and that module, and that's another license.
For sure, but I'm sick and tired of buying products that are one size fits all.
But can it just be free?
There you go.
Yeah, we'll take ads.
Somehow I see the VC firms right now just going.
They're just twitching in their head.
We withdraw our funding for the Yeah.
Okay, I mean, I think Anand will just
Yeah.
now talk about the performance side of this IoT stuff.
Exactly. Thanks, man.
Hey,
I
no problem.
appreciate it. Yeah. So any thought, I mean, do you guys, again, like, so when you think about IoT devices in your customer, your environments, how do you guys think about sort of, what are the problems that you guys are thinking of? Like what's top of mind?
Comment, I'm sorry, to, kind of follow up with Sam, follow up on what's. So like the medical devices, you can use all of this intelligence to identify what medical devices you have. Or you can do a packet capture and ask the purchasing department. I mean, I'm just trying to, and I don't mean to be a wise guy, I'm just saying, what is that's being delivered that can't be found other lower cost ways just based on these couple of slides? What's the goal of that?
Yeah, I mean, no, for sure. I mean, what we see is, for people that have it top of mind, it's sort of there are some things that I know about, and part of IoT is it's installed by somebody else, right? Or like it sort of ties to whether it's a line of business or the purchasing department or facilities or whoever is sort of installing this stuff. So in some cases, it's, hey, what is even on my network, right? And what do I even need to look at from a quirky behavior standpoint? A lot of times what'll happen is some of the worst performing clients will turn out to be, some, IoT device or Apple Watch or something like this, that it's like, oh, crap, I didn't care about that or something like that. So there's one aspect to just kind of know what's there and to be able to focus on it or ignore it. There's the other side of, hey, I know that these are my most important devices. And again, I mean, it differs in verticals, right? For sure, right? I mean, there's that aspect of it. But
I think this information though aligns well with the triage use case. I think you said it well, right? You've got GE rolling into a place. How do I know this is going to work well?
Yep.
But the productization of the way the product sits today is that it's not meant for that MSP triage style use case.
Yep.
It strikes me that you would go after the IoT device manufacturers in some sort of a product that would say, we're going to do readiness assessment for our widget on your network, not necessarily go after all of the direct owners of the networks.
Yeah, or
that's
like
a
how
better
you use
idea.
tools to do a port scan to find out what's misconfigured. Like this could be used to automatically group and identify things that you weren't even aware that were on your network, or detectable, maybe not.
Yeah, because sometimes you need to separate what's from a clinical point of view on a clinical
And it would
like
be
if you're
interesting
gonna
if they were like auto grouped together on like their own little dashboard tab or something. Like do you
For sure.
know even that these things exist?
I mean, the Alerus pump is actually probably it's an interesting example because my experience with those pumps has been you'll get a CF wireless card plugged into the back, and the drivers are 10 years old, and nobody's updating them because the card's discontinued.
right.
But I'm sorry, Alerus. Really, figure it out. I mean,
That blows my mind. Something is that important.
and the machine is $1 billion, right? It's $1 billion for that machine, and they've put this $2 card that they went and got a whole bunch of. I'm sorry, Alerus, to pick on you, but it's you got a great machine, but when you're trying to get database updates from pharmacy to push in new updates for medication into the pump, well, if these devices drop off the network, they kind of have to be rebooted. And
Well, until recently, at least in the U.S., the FDA rules prohibited modifying the device in any fashion after it was approved.
Yeah.
Now, that's been relaxed over the last couple of years or so. I can't remember when the date exactly was, to allow you to do things like change a wireless card out or stuff like that. But still, to the level of things that we need to do to the device to make it perform well on the wireless side, right? Because what I've been in a number of hospital environments where customers have just simply said, well, we bought it to use it as wireless because we wanted the ability to just move it around. It's got a backup battery in it and things like that. But it behaves so poorly that we just plug it in now.
there are ECG cards in the same boat, right? They can't change the wireless drivers because
I know about all my IoT devices. They always plug them in and they go, yeah, it's going to work great, and then it doesn't. I usually get a call about 5 minutes after they plug it in, and they go, hey, it doesn't work. And so then all of a sudden you go through and you can classify everything because you go, wow, how many of these did you install? And they go, yeah, we installed 200 and none of them work. Great. You didn't bother to tell me. It just
Exactly.
So going back to what Amy said and kind of pigtailing off of yours, I personally see this side of the product, especially with regards to IoT. Now, it really fits across the board on all products, but I see this as a big potential security play for customers, especially if you guys have tie-ins to Fortinet, Palo Alto, Checkpoint, those guys. So you can say, hey, if you see a IoT device that we've never seen before, or we already know what classification it is, like it's an IV pump or a sprinkler system or whatever device category X is, provision it on the firewall to have this policy, right? Or since you're tracking hosts and who they talk to and all like that, hey, that's anomalous. Send a trigger to the firewall and say, quarantine, block temporarily, whatever, this MAC address.
I think that seems, I could see more use cases in that as opposed to, oh, this device behaves like this. Well, I mean, I have devices that key up once an hour and they send one number. This is how many people came through this door. And so you go, great, I got one packet every hour. And so I know that's what that is. And so it just, I feel like the security aspect of being able to say, hey, this has come up, and this isn't something that we've seen before. This is something new. At that point, you can kind of, it flags it, and you can, and then as somebody who runs Wi-Fi systems, you can say, hey, this is a new anomaly, and you can find out about it, when the first one goes in, not when the 200th one goes in.
So let's just take out the elephant in the room. Are there plans for Nyansa to tie into security ecosystem? Are you in discussions with the firewall guys, right, to build upon the knowledge you have and what their products can do for users at the end user level?
So there you go. No. So the way we're thinking about it is this, right? The first, it's kind of the Maslow's pyramid of needs a little bit. The first problem with IoT is knowing what they are. The second is kind of, making sure that they can connect and making sure that they can even perform their line of business duties, because otherwise the whole thing is pointless, right? And then we sort of see the security thing as sort of the third problem therein, right? But where we want to focus, at least right now, is sort of, all right, let's capture the first two, right? Since we have so much leverage there already, right? We're already looking at it. But it's totally fair, and we've had instances where some of the data that we've analyzed and unearthed, our customer, the network engineer, is like, hey, this is interesting. Let me go tell my security guy about this or whatever it is.
Well, I mean, that's just a nudge. Maybe you want to think about that direction. But, especially when, like Lee said earlier, his point about we already have a lot of insight into our network. Maybe not to this level of granularity with our clients, but if I'm going in as a VAR to try to sell a customer on buying Nyansa, if they have concerns about yet another dashboard or X, whatever that concern may be, right? Or it's a cost or whatever, that's another value add to their network, I think.
No, for sure, No, it's a really good.
And I know you guys are young. Don't get me wrong. I'm not acting like you're a 10-year-old company and you can evolve rapidly into things like that. But that's where I see the product going.
Okay, no, nice.
Do you want to have a comment? I mean, to be fair, I think there's an interesting piece. So I touch all of our customers and work with them.
That sounded really bad, John.
Notice we all let that go.
Customer success said yes.
I think that you had such a hands-on approach.
Very high touch model. Above the way. Anyway, so where was I? Oh, right, API. So no, I think one of the fastest and sort of most interesting sort of growth area we hear from a lot of our customers is how do I take the data that you have that Nyansa has, right, and push that into other systems. So there's a lot of discussions around APIs. And we have an API today, and we're building more of that API out. Because I think that there is an aspect where people don't want a sixth or seventh or eighth single pane of glass, and
because at that point they're really not single pane.
No. Well, I have 10.
You have the Jeopardy board in the office with everything going.
But I do think that there's a lot of call for integrating the data that you have into other systems and being able to push that out, and it takes a certain amount of pride or confidence, right, to say I'm okay with that. I don't have to have you look at the dark theme or the light theme. I'm really okay with being a great provider of insights and information and feeding that in through an API. So I definitely see that growing, and I think that is certainly where we would see a lot of integrations down the road.
Because at some point, right, all of this data, while it may be great to people like us. A lot of customers have a lot of devices, very few network people. There's not a lot of time in the day as is to look at logs and things like that. That's why they pay other companies to come in and do that for them, right? So if there's some way to provide instant value to the customer, in a small scale, right? Because I do agree with you. That's a lot of even my concern with APIs and automating things within the network, especially on the security side of things and all.
No, for sure. Okay, cool. So some actual examples, and I'll definitely touch on Trent's question as well in terms of radius server integration and what that looks like in the product.